In question 1, it says that showing all necessary workings, solve the equation ln of x power 4 minus 4 is equals to 4 ln x minus ln 4, giving answer correct to decimal place. In the first step, what you will do is you will first simplify. Can I write ln 4 ln x as ln x to the power 4 minus ln 4? Okay, and now because there is a negative sign, I can write on the right hand side as ln x power 4 upon 4. Now we can compare the left and the right hand side. So this will become x
सर
minus 4 is equals to x power 4 upon
सर
4,
वो x पावर 4 है, x स्क्वायर नहीं है.
x power 4, right? So this will become x power 4 minus 4. Cross multiplying, this will become x power 4 minus 4 is equals to x power 4
-16.
minus 16. So this will become 4x power 4. मैं इसको करेक्ट कर लेता हूं. This will become 4x power 4 minus 16 is equals to x power 4. So this will be 3x power 4 is equals to plus 16, right? So x power 4 will be is equals to 16 upon 3. So x will be is equals to root 4 16 upon 3. Whatever the values, can someone please calculate this in their calculators? Tell me what the answer is. Root 4
1.52.
1.52, we have to give to two decimal place, so this will be x is equals to 1.52. Okay. In question 2, it says given that sine x minus 60 is equals to 3 cos into x minus 45, find the exact value of tan x. In the first step, we expand using the वो जो additional identity थी, सही है. Sin x a minus b की होती है, that is sin a cos b minus cos a sin b. So this is sin x cos 60, and this will become minus cos x sin 60 is equals to 3 times cos x minus 45. So this will become cos x cos 45 plus sin x sin 45, right? Okay. Cos 60 is root 3 by 2. So root 3 by 2 sin x minus root 3 by 2, because sin 60, अच्छा नहीं, cos 60 is half, right? So cos 60 is half, sin 60 is root 3 by 2. Okay. Cos 45 is root 2 upon 2, सही है? So this will become 3 root 2 upon 2 cos x. Sin 45 is also root 2 upon 2. So this is sin x sin 45, ठीक है? So this will be 3 root 2 upon 2 sin x. Acha, now to simplify, bring the cos terms together and the sin term together. So let's bring this over here. This will be 1 upon 2 sin x minus 3 root 2 upon 2 sin x, ठीक है? Is equals to, this will be 3 root 2 upon 2 cos x plus root 3 upon 2 cos x. Adding them up, this will become 1 minus 3 root 2 upon 2 sin x is equals to 3 root 2 plus root 3. ये पूरा cos x के साथ आ जाएगा, right? Upon 2. 2 and 2 cancels. Ab we have to bring tan, so let's put this in bracket. Let's bring the cos over here and this over here, right? तो हम इसको कैसे लिख लेंगे? We can write this as sin x upon cos x is equals to 3 root 2 plus root 3 upon 1 minus 3 root 2. Exact value, it means you can leave your answer as it is. ठीक है, तो we know sin x upon cos x tan x is, so we can write tan x is equals to this thing, 3 root 2 plus root 3 upon 1 minus 3 root 2. In the mark schemes, what they do is इसको rationalize कर देते हैं. So they multiply the numerator and the denominator by 1 plus 3 root 2. Changing the sign of the denominator, they rationalize it, but still, even if you leave an answer in this form, this is correct. Hence, solve the equation. Well, all you have to do is now do tan inverse of this value. So x will be is equals to, please put in the calculator tan inverse of 3 root 2 plus root 3 upon 1 minus 3 root 2. What is the value? Minus 61. Let's consider the positive value. सही है. 61.5, but we'll take it in the negative quadrants. मतलब of 10. सही, तो this is 61.5 and this is 61.5. ठीक है. Now to find x, one of the angles will be 180 minus 61.5. What is the answer? And the other value will be 360 minus 61.5. 118.5, and the second answer is 298.5 degrees. Acha, let's start. So in this question, a curve has equation y is equals to e power 3x upon 10 half x. Find the x coordinates of the stationary points of the curve. Stationary points mean that dy dx will be is equals to 0. That's the first thing that you should be able to recognize in the question. Give your answer correct to 3 decimal place. Now, as these two terms are dividing, we'll use the product rule. We know that dy dx, if two terms are dividing, is vu dash minus uv dash upon v squared. It's better that you write u separately. U is equals to e power 3x. So u dash, or the derivative, will be 3 e power 3x. We take the derivative of 3x and multiply. V will be is equals to tan of half x. V is tan of half x. So v dash will be derivative of tan is sec square x. So this will be sec square half x. And we'll also multiply with the derivative of half x, which is half. So this will be half sec square half x. Now we'll just substitute these values in the calculator, in the formula. Okay, so this will be vu dash. So 3 e power 3x multiplied by tan half x minus uv dash. So that will be half e power 3x sec square half x upon v squared. V squared will be what? Tan half x whole squared. Now we'll substitute it equals to 0 because it's talking about the stationary point. So tan half x multiplies over here and becomes a 0, right? We can take this negative value on the left hand side and write it as a positive value. So this will become half e power 3x sec square half x is equals to 3 e power 3x tan half x. This is tan half x. Okay, e power 3x and e power 3x on both the sides cancel, right? Now, as we have to solve this equation, I have sec square over here and tan over here. Can I bring them like in the same trigonometric term, sine, cos, or tan? I can use the identity over here, which is 1 plus tan square is equals to sec square, right? 1 plus tan square of x is equals to sec square of x. So in place of sec square, I can write 1 plus tan square. So, acha, to make it easier, bring the 2 over here, say make it 6. On the right hand side, I will have 6 tan half x. And on the right hand side, in place of sec square half x, I can write 1 plus tan square half x. Bringing that 6 tan x on this side, acha, I'm writing it in short form now. Tan square minus 6 tan plus 1 is equals to 0. Using a calculator, solve this quadratic equation better. Okay, so we have tan half x as 0.172 and tan half x as 5.83. We have to solve between 0 and pi. ठीक? In radians, yeah. So what is tan inverse of 0.172 in radians? Zero point 170, and tan inverse of 5.83. 1.40, but 1.40, that's enough. Chalo. Now listen, beta, dekho. To make sure that we don't miss out on any angles, I know that tan is positive in this quadrant and this quadrant, right? So one of the angles is 0.170, the other angle will be pi plus 0.170, right? So I can write as pi plus 0.170. However, when I multiply by 2, the value beyond pi chali jayegi, so I can ignore this value, right? So one of the values of x will be half x is equals to 0.170. So x will be 2 times 0.170, so 340 ho gaya, right? Clear? And from over here, if I just multiply by 2, this will become 2.80. Is this less than pi? Yes, it is. So it means this will be my second answer. The other answer will be beyond pi, so we can ignore it. Important cheez hai to get an A. In the question, it said give your answer correct to 3 decimal place. If I'm giving my answer to 2 decimal place over here, I will lose a mark. Say in exam, you will definitely lose a mark. Okay. It says in question 4 that the polynomial is divisible by x square minus x plus 1. When it says divisible, it means that the remainder will be 0, right? So in the first step, what we'll do is we'll just start dividing these two terms. So we have over here x power 4 plus 2x cube plus ax plus b. And this is x square minus x plus 1. In the first step, what we do is we write x4 upon x square. So this will become x power 4 upon x square. This will be equals to x square. We write the x square over here and then multiply. So when we multiply, this will become x power 4 minus x cube plus x square. And we subtract this from this term. Say, so x power 4 minus 4, that will become, well, that will cancel out. 2x cube, and this will become a plus x cube. So this will become 3x cube, ax minus x square. So this will remain as ax minus x square and plus b. Okay. Now in the next step, what you do is you write 3x. What happened to this 2? As a 3x cube. Okay. So 3x cube upon x square. So this will cancel out and I will have 3x. So you will write plus 3x over here and then multiply 3x with this whole term. So this will become what? 3x cube minus 3x square plus 3x. ठीक, and then basta, that's it, I think. Okay. So now subtracting 3x cube and this will cancel. Minus x square and this will become plus 3x square. तो ये हो जाएगा 2x square plus 2x square. Say this will be plus ax plus minus 3x and then plus b will remain as it is. Right? Once we have done with this, now in the next step you divide 2x square by x square. So this will be is equals to 2. So you will put a plus 2 over here and then multiply again. What I will get is 2x square minus 2x plus 2. Again, we are subtracting. So this will become minus, this will become plus, and this will become a minus. So ax plus 2, this is plus ax plus 2x minus 3x. So this will become ax minus x minus 2 plus b. And that is it. ये क्या हुआ है? But I think that is it. So this will be is equals to 0. This is the remainder, right? ठीक है ना? This whole thing is equals to 0. It means the x terms and the constant term should have cancelled out, right? So it means that the coefficient of x should have been 0. So a minus 1 is equals to 0. A is equals to 1. And minus 2 plus b should have also been equals to 0, right? So b will be equal to 5. B is equals to positive 2 aa raha hai. In substitution, the first step is always you differentiate the given substitution. So as x is equals to cos square theta, you will say sir dx by d theta will be is equals to 2 cos theta, and the derivative of cos theta will be minus sine theta. So let's put a minus over here and sine theta, right? Now I have this over here, right? I have root of x upon 1 minus x dx. In place of dx, can I write minus 2 sine cos d theta, right? In place of dx, I will replace dx with minus 2 sine cos d theta, right? Okay, this is the integral sign. We'll change the limits after we are done with the substitution. Now, x is equals to cos square theta. So in place of x in the numerator, I can write cos square. In the denominator, it will be 1 minus cos square. Agreed? Okay. 1 minus cos square is sine squared. So this will become cos squared upon sine squared into minus 2 sine cos d theta. Clear so far? Okay. Square root, when we the square root and the square will cancel out. This will be cos upon sine into minus 2 sine cos d theta, right? Okay. Sorry, sine and sine cancels out, right? So this will become minus 2 cos square theta d theta, right? Clear ho gaya yahan tak? This is what we had to prove. And now coming to the limits. So we know that the substitution was x is equals to cos square theta. One of the values of x is 3 upon 4. Can you square root 3 upon 4 and then cos inverse? Beta, haro. Square root of this. So theta will be or x na theta will be cos 1 over 6 pi. 1 over 6 pi na? Okay, 1 over 6 pi. This is what we had to show, 1 over 6 pi. Acha, and the second value of x was 1 over 4. So root 1 over 4 करके cos inverse कर दो. You square root 1 over 4 and then cos inverse. That should be 1 over 3 pi. सही, 1 over 3 pi. अच्छा, now what happens is आप लोग please को देख लो. Which of these values is larger? This is the larger value, right? And this is the smaller value. What you're observing is कि जब मैंने x की larger value ली तो theta की smaller value आ रही है, right? तो इस केस में because now I have to put 1 over 3 pi over here and 1 over 6 pi over here, the sign changes. क्योंकि ये पूरा flip हो गया है तो इसका sign change हो जाता है. This will just become 2 cos square theta d theta और ये आ गया 1 over 3 pi 1 over 6 pi and that is it. Revision for you all, how to integrate. So I have to integrate what? This is cos square theta. Let's forget about the limits for the time being. What we learned was that we cannot integrate sine squared and cos squared terms. So we use a substitution. Excellent. So the substitution is cos 2 theta is 2 cos square minus 1. So cos square theta will be cos 2 theta plus 1 upon 2. Right? So this will become cos 2 theta plus 1 upon 2. Leave the 2 outside and d theta. Now we know when we integrate cos, we get sine 2 theta upon 2 positive. So this will be plus 4. When I integrate 1 upon 2, that will become 1 upon 2 theta. And finally, what you will do is you will multiply the whole thing by 2, or you can not multiply. You can just substitute the limits first, whatever you find easy. Please keep your calculators in your hand. So this will become 2 sine 2 theta upon 4 plus 2 into half will be theta. Let's simplify it further and write it like this. 1 upon 2 sine 2 theta plus theta. So this is our final integral. The limit was 1 upon 3 pi. So this will be 1 upon 2 sine of 2 upon 3 pi plus 1 upon 3 pi. Sine 2 upon 3 pi in the calculator is what? साइन √3/2 होता है, सही है, -√3 नहीं +√3/2, so this will be √3/4 plus 1/3 pi minus this will be sine of 1/3. Sine of 1/3 is also √3/2. So this will become √3/4 plus 1/6 pi. ठीक है? Opening the bracket, this will cancel out. The final answer will be 1/3 pi minus 1/6 pi, or LCM ले लो, which is 6. So this will become what? 2 pi minus pi upon 6, right? So the final answer will be pi by 6. In question 6, it says that in a certain chemical reaction, the amount x grams of a substance is decreasing. The differential equation relating x and t, the time in seconds since the reaction started, is given as dx by dt is equals to minus kx root t, where k is a positive constant. It is given that x equals to 100 at the start of the reaction. In part 1, we have to solve the differential equation, obtaining a relation between x, t, and k. Now, to solve a differential equation, the first step is to separate the variables. So with dx, we need to have the variable x. So we'll bring the x on the left-hand side and we'll write it as dx upon x. And we'll bring dt on the right-hand side. So that will become minus k root t dt. Now, once we have done that, we'll just integrate both the sides. We'll put the integral sign. Now, we know that the integral of 1 upon x, that will become ln of x. And this is root t, which is t to the power half. When we are integrating, we add power 1 and then divide by the new power. So that will become t to the power 3/2. And when we divide the fraction by 3/2, we can write it as 2/3. So that will become minus 2/3k t to the power 3/2 plus c. Now, it's also given that x equals to 100 at the start of the reaction. That means when t equals to 0, x equals to 100. So we'll substitute this in the equation to find the value of c. So this will be written as ln of 100 is equals to t is 0. So this whole term becomes 0 plus c. So we know that the value of c is 100. So the differential equation can now be written as ln of x is equals to minus 2. So that's minus 2/3 k t to the power 3/2 plus ln of 100. In part 2, it says that given that t is equals to 25 when x equals to 80, we have to find the value of t when x equals to 40. Now, using this information, we can first find the value of k. So we have the original equation, and in place of x, we can write 80. So that will become ln of 80 is equals to minus 2/3 k, and t is 25. So 25 to the power 3/2 plus the value of c, that was ln of 100. Now simplifying this, we can bring this on the left hand side and that will become plus 2/3. We know that 25 to the power 3/2, substituting this in the calculator, that will become 125. So we can write this as 125 k is equals to, and then 80 comes on the right hand side, that becomes ln of 100 minus ln of 80. This will become, so this will become 250 upon 3k is equals to, now we can write this as ln of 100 upon 80, or we can simplify and write it as 5/4. So the value of k is, cross multiplying 3 and 250, we'll get 3/250 ln of 5/4. Now we have to find the value of t when x equals to 40. So in this original equation, in place of x, we can now write ln 40 is equals to minus 2/3 into k. We have the value of k, which is 3/250 into ln of 5/4 into t to the power 3/2 and then plus ln of 100. Finding the value of t, we can bring this term on the left hand side. This 3 and 3 will cancel. We can write this as 1/125, and this will become positive. Ln of 5/4 t to the power 3 upon 2 is equals to ln of 100 minus ln of 40. Now, simplifying this further, so we can separate t to the power 3 upon 2. This will become ln of, we can write it as ln of 100 upon 40, or we can just directly substitute this in the calculator as well. So 125 will multiply, and then this ln of 5 by 4, this will divide. So we'll divide this by ln of 5 by 4. Once we substitute this in the calculator, this is t to the power 3 upon 2. So to get rid of this, we'll have the root of 2 upon 3. So we'll have to root this by 2 upon 3 as well. And then when we substitute this in the calculator, we'll get the value of t as 64.107. As we have to give our answer to 3 significant figures, so final answer will be 64.1. In question 7, it says that showing all your working and without using a calculator, solve the equation z square plus 2 root 6z plus 8 equals to 0, giving your answer in the form x plus I y. So as it is a quadratic equation, we'll just simply apply the quadratic formula. Now the coefficient of z square is 1, so a will be is equals to 1. The coefficient of z is 2 root 6, so b is equals to 2 root 6. And the constant term is 8, so c is equals to 8. Now applying the quadratic formula, that is minus b, so this will become minus 2 root 6 plus minus b squared minus 4ac. So b is 2 root 6, we'll write it as 2 root 6 whole squared minus 4ac divided by 2a, so 2 times 1. Now simplifying the numerator, we'll get minus 2 root 6 plus minus, so square of 2 is 4 and square root of 6 whole square, that is 6. And 4 times 6 will become 24. So that will become 24 minus 32 divided by 2. We'll get minus 2 root 6 plus minus, and 24 minus 32 is minus 8. So this will become minus 8 divided by 2. Now, taking square root of minus 8 separately, we can write it as square root of 8 multiplied by square root of minus 1. We know that square root of minus 1, that is iota, and square root of 8, we can write it in surd form, and we can write it as square root of 4 multiplied by square root of 2. So square root of 4 is 2, so that will become 2 root 2 iota. So in place of square root of minus 8, we can write 2 root 2 iota. So this will now be written as x is equals to minus 2 root 6 plus minus 2 root 2 iota divided by 2. 2 and 2 will cancel out. Within 2 will cancel out with the numerator. So we'll get minus root 6 plus minus root 2 iota. So the two roots will be, we can write it separately as minus root 6 plus root 2 iota. And the second answer is minus root 6 minus root 2 iota. In part C, it says sketch an Eigen diagram showing the points representing the roots. So we can just first make the x and the y axis over here. And we know that the imaginary value is on the y-axis. So let's say this is the point root 2. This is the point minus root 2. And the real value is represented on the x-axis. So we can take this as minus root 6. So one of the coordinates is minus root 6 plus root 2 iota. So one of those points will be over here. And we can label it as x1. So let's say this was x1. And the other point is minus root 6 minus root 2 iota. So we can label this point as x2. And let's say this was written as x2. Now it says the points representing the roots are A and B, and O is the origin. We have to find the angle AOB. Now to find the angle AOB, we already have made this Argand diagram. This is the origin. So quickly making the same points separately over here. Let's say this is the point, this is root 2, this is minus root 2, and this is minus root 6. So this is point A, this will be point B, and this is the origin. So we can just simply make a triangle. Once we have made this triangle, this is point B, this is point O, we have to find the angle AOB. Now, to find this whole angle, we know that this length over here is √2 and this length is √6. So if we can just find this angle, we'll multiply it by 2. So we can use tan inverse of √2 upon √6, and that will give us this angle AO, and let's call this point as, let's say this was C. So angle AOC, that will be is equals to tan inverse of √2 upon √6. Substituting this in the calculator, the value will be 30. So if this angle is 30, the total angle AOB will be 30 times 2, which is 60 degrees. In part 4, it says that prove that AOB is equilateral. Now, as we already know that these two lengths will be exactly the same, so we know that OAB will be is equals to OBA. And as one of these angles AOB is already 60, so let's say this is 60, so we can just say 180 minus 60 is equals to 120. And as the remaining angles are equal, when we divide by 2, each of these angles will come out as 60. So that will be enough of an explanation to get the 1 mark. In question number 8, it says that the positive constant A is such that x to the power e minus half x equals to 2 with limits a and 0. We have to show that A satisfies the equation A is equals to 2 ln of A plus 2. So as we can see that in this question, there are two different functions that are multiplying. So we'll have to use integration by parts. We'll use the late method, and it basically means that whatever function comes up, that will be taken as u. As we know that when we do integration by parts, this is the formula. So these are the two functions. One of them is u and the other is dv. And the formula is uv minus v du. So whichever function comes up first, that is taken as u, and then the function after that is taken as dv. As we have one algebraic function and the other is an exponential function, so we can take u as, we will take u as x, as it's an algebraic function. So du will be is equals to 1, and e power minus half x will be taken as dv. So v will be is equals to, so when we integrate this, this will become e power minus half x divided by minus half. So when you divide by minus half, the negative 2 will come in the numerator. Now substituting this into the original formula, we will get, so uv will become minus 2 e power minus half x into x. So that will be minus 2 x e power minus half x minus, and then v du. Du is 1 and v is minus 2. So this is minus 2 e power minus half x and du is 1. Now integrating this function, so this will become 2x e power minus half x. Minus minus becomes a plus. We'll keep the 2 over here. And integrating e power minus half x, we'll again get e power minus half x. And when we divide by minus half, the minus 2 will multiply over here. And this, after applying the limits, that will be equals to 2. Now substituting the limits over here, this will become minus 2. This will become a e power minus half a. And this is minus 4 e power minus half. And in place of x, we can substitute an a. And then the lower limit, when we substitute it over here, that will become, so the lower limit is 0. So substituting 0 in place of x, will get 0 over here. So that will become 0 minus, and substituting 0 over here, so this term will become a 1. So that will become minus 4 equals to 2. Now simplifying, we'll get minus 2a e power minus half a minus 4 e power minus half a plus 4 is equals to 2. Now, as we have to make a the subject over here, what we can do is we can bring this on the right hand side. So this will become minus 2a e power minus half a is equals to 2 minus 4 is minus 2. So that will become minus 2. And taking this on the right hand side, this will become plus 4 e power minus half a. Now in the next step, we will divide minus 2 e power minus half a on the right hand side. So a will be is equals to minus 2 and minus 2 will make it a 1 upon, and this will be in the new denominator, minus half a. And then 4 divided by minus 2, so that will become minus 2, and e power minus half a and e power minus half a will cancel. Now taking minus 2 on the left hand side, we'll get a plus 2, and we can bring this in the numerator, and that will become e power minus half a. Now we can bring in the natural log function. So introducing ln on both the sides, we'll get ln a plus 2 is equals to ln of e power minus half a. Minus half a will multiply over here, so that will become minus half a. Okay, and this will become a plus as we brought it in the numerator, so this should have been a plus over here. So this will become half a ln of e, which is equals to 1, is equals to ln of a plus 2. So the final answer will be a is equals to 2 ln of a plus 2. In part 2, we have to verify by calculation that a lies between 3 and 3.5. Now the method to do this is we'll first bring the whole equation on the left hand side and write it equals to 0. Now to show that a lies between this, we have to show a change of sign. So first taking the value of a as 3, we'll substitute 3 over here, we'll get 3 minus 2 ln of 5. This will become 3 minus 2 ln of 5, that is minus 0.218. And now substituting a is equals to 3.5. So we'll get 3.5 minus 2 ln of 5.5. So 3.5 minus 2 ln of 5.5, that is 0.09. So that's a positive value. Now this change of sign shows that the root lies between 3 and 3.5. Now in the next part, we have to use an iteration to find the value of a. Now we can take the initial value of a as between 3 and 3.5. So we have a is equals to 2 ln of a plus 2. Let's take the initial value of a as, we can take it as the value between 3 and 3.5. So that is 3.25. So getting the first value, so let's say this is the initial value. So the first value will become 2 ln of 5.25. Substituting this in the calculator, we get 2 ln of 5.25. Now that is 3.316. And now we can just keep on substituting these values. And we have to write each iteration to 4 decimal place. So that will become 3.31645. So that will make it 3.3165. The second value will substitute in place of x 3.3165. So that will be 2 ln of 3.3165 plus 2. So ln of this answer multiplied by 2, that makes it 3.34. So that is 5.3165. This will be 3.3416. Now I'll substitute this again. So that will be 2 ln of 2 plus 3.3416. We'll get 3.351. So this will become 3.35105. And we just have to show one of the iterations with complete working, and then we can simply substitute this in the calculator to get the remaining values. So this was the third value, and we have to make sure it comes up constant up to 2 decimal place. So the fourth value will be 2 ln of, so 2 plus 3.35105, and that will become 3.354. And just doing it one more time, so that will become 2 into ln of 2 plus 3.354. I didn't write it to 4 decimal place. We have to make sure we write all of these values to 4 decimal place. 2 plus 3.354. And again, we are getting 3.35. So this is getting coming out as 3.3556. Just doing it one more time. So that will become 2 ln of 2 plus 3.3556. And again, we are getting 3.356. So now the final answer, we can write it as 3.36. So the final answer for A will be A is equals to 3.36. In question 9, it says that let f of x be 12x squared plus 4x minus 1 upon x minus 1 into 3x plus 2. In part 1, we have to express f of x in partial fractions. Now, just by looking at the fraction, you'll think we'll write it as a upon x minus 1 plus b upon 3x plus 2. However, we have to be careful of one thing, and that is if the power of x in the numerator and denominator is equal. So in the numerator it is x square and in the denominator is x squared as well. Then we cannot write the partial fraction like this. And that is because if we take the LCM, we multiply a by 3x plus 2 and b by x minus 1, we will not get a squared term in the numerator. So if the powers are equal, this is called an improper fraction. We'll write the partial fraction as a, that will add a constant, plus b upon x minus 1 plus c upon 3x plus 2. When we take the LCM, a will multiply by x minus 1 and 3x plus 2. B will multiply by only 3x plus 2. And c will multiply by x minus 1. And this numerator is equals to 12x squared plus 4x minus 1. Now to find the values of a, b, and c, we can start by first assuming. So let's say if we take the value of x is equals to 1, this term and the a term and the c term will cancel out. So substituting x is equals to 1, we'll get 12 plus 4 minus 1 is equals to a. 1 minus 1 is 0, so the whole term becomes 0. B into this will become 3 times 1 plus 2, that is 5, plus, and this will become a 0 as well, as 1 minus 1 is 0. So I get 12 plus 4 is 16 minus 1, 15 is equals to 5b. So b is equals to 3. To find the value of c, we can take the value, one of the values of x as minus 2 by 3. As if we take minus 2 by 3, the a and b terms will cancel out. So now taking x is equals to minus 2 by 3, we'll get 12 into minus 2 by 3 whole squared plus 4 into minus 2 by 3 minus 1 is equals to, so this will become 0, plus b will also become 0, and this will become minus 2 by 3 minus 1. Simplifying the left hand side, we'll get 12 into this will be 4 upon 9 minus 8 upon 3 minus 1 is equals to, so minus 2 upon 3 minus 1, that is minus 5 upon 3c. So this will be 36 upon 3 minus 8 upon 3 minus 1 is equals to minus 5 upon 3c. 36 minus 8, that is 28. So 28 upon 3 minus 1 is equals to minus 5 upon 3c. Taking the LCM again on the left hand side, we'll get 28 minus 1 or 28 minus 3, which is 25 upon 3 is equals to minus 5 upon 3c. 3 cancels out. So c will be equals to 25 upon minus 5, which is minus 5 is equals to c. I hope मैंने कोई mistake नहीं करी हुई. Anyways, and to find the value of a, we can take any value of x. We can take, as we already have the values of a and c, we can just substitute x is equals to 0 over here, and we can find the value of a. Okay, just confirming the answer. So b is equals to 3, x is equals to minus 2 by 3, that is 4 upon 9. Okay, there was a mistake over here. So that 3 threes are, this should have been 3 fours are. So this would have been 4 times 4 is 16. 16 minus 8, this would have been 8. 8 upon 3 minus 1, so that would have become 5 upon 3. And then 5 and 5 also cancels out. So the value of c would have been equals to minus 1. So the value of c is minus 1. Now, once we have the value of c, to find the value of a, we can assume any value of x. The easiest value to assume is x is equals to 0. So when we take x equals to 0, this will be 0, this will be 0, and this will be minus 1 is equals to a into 0 minus 1 is minus 1 into 3 times 0 is 0 plus 2 is 2 plus the value of b is 3. So 3 into 0 plus 2 is 2, and then plus c, the value of c is minus 1, and 0 minus 1 is minus 1. So we'll get minus 1 is equals to minus 2a plus 6 plus 1. So -1 and 6 plus 1 is 7. And -1 minus 7 is equals to -2a. So -8 is equals to -2a. And a will be is equals to 8 upon 2, which is equals to 4. In part 2, it says, hence obtain the expansion of f of x in in ascending powers of x up to and including the term in x squared. So first we'll write the expression, that is 4 plus the value of b is 3. So that will become 3 upon x minus 1. And the value of c is -1. So that will become -1 upon 3x plus 2. We'll first bring uh, x minus 1 in the numerator. So we'll write it as x minus 1 to the power of -1. And this will be 3x plus 2 to the power of -1. Now to expand it, it is better if we have it in the form 1 plus x, if we have the 1 as a positive value. So we can write it as 4 minus 3, and we can write it as 1 minus x to the power of -1. And over here, we can take 2 common, and we can write it as 1 plus 3x upon 2 to the power of -1. Now, first expanding the first term, so this will be 4 minus 3 into, the formula is 1 plus nc1. So as n is -1 and nc1 is n, so this will become -1 into b. So b is minus x plus nc2. So nc2, we write it as n into n minus 1 upon 2 factorial. N is -1, so that will become -1 into -1 minus 1 is -2 upon 2 factorial multiplied by x squared, b squared. So that will become minus x whole squared. Now expanding the second term, we'll get 1 plus nc1 will again be -1. b is 3x upon 2. And then plus nc2 will be -1 into -2 upon 2 factorial into 3x upon 2 whole squared. Simplifying, we'll get 4 minus 3 into, this will become 1 plus x, minus minus cancels, 2 and 2 cancel, so 1 plus x, and this will also become a plus x squared, minus 2 into 1 minus 3x upon 2, minus minus will become a plus, and this will become plus 9x squared upon 4. Opening the bracket, we'll get 4 minus 3 minus 3x minus 3x squared minus 2. And then 2 into 3x upon 2 will become plus 3x. Right? And then, where did this 2 come from? Ye wala 2 kahan se aaya? Okay, one mistake. When we take common out, this would have been 2 power minus 1. So 2 power minus 1 will be written as 1 upon 2. So we'll have to write 1 over 2 over here. So this will become 1 over 2. So 1 over 2 into 1 is 1 upon 2. This will become plus 3x upon 4. And minus minus is minus plus is minus. So that will become minus 9x squared upon 8. Simplifying, we'll get 4 minus 3, 1. And 1 minus half is half. Then these are the x terms, minus 3x plus 3x upon 4. So minus 3x plus 3x upon 4. So that is minus 12x plus 3x is minus 9x upon 4. And then simplifying the squared term, so that is minus 3x squared and minus 9x squared upon 8. So minus 3x squared minus 9x squared upon 8. Taking the LCM, 8 is a 24. 24 minus 9 will become minus 33. So that will become minus 33 upon 8x squared. Question number 10. The point P has vector position vector 3, -2 and 1. The line L has the equation R equals to 4i plus 2j plus 5k plus mu into I plus 2j plus 3k. In part 1, we have to find the length of the perpendicular from P to line L, giving our answer correct to 3 significant figures. Now, in this case, and this question does come up very regularly in your exam, the first thing you have to do is, let's make a point P and let's assume this is the line L. So we have to find the distance, the length of the perpendicular. So let's say this is the perpendicular and let's call this x. So in actual, we are trying to find this length px. Now to find the length of px, we need the coordinates of x. To find the coordinates of x, what we'll do is, we know that the equation of the line can be written in the form. So this is 4 plus mu into iota. So that will be 4 plus mu into 1 will be mu. 2 plus 2 mu, 2j plus mu into 2j, that will become 2 plus 2 mu, and this will become 5 plus 3 mu. Now, as this line and this line px are perpendicular, what we know is that the direction of px and the direction of the line L, that will be equals to 0. Now, we already have the direction of line L, that is 1, 2, and 3. To find the direction of line px, we'll first write px is equals to x minus p. Now, the x coordinates we do not have, but we can write the x coordinates as it lies on line L. So the x coordinates will be of the form 4 plus mu, 2 plus 2 mu, 5 plus 3 mu, and subtracted from the coordinates of p, which are 3, minus 2, and 1. Simplifying this, we'll get, so 4 minus 3 will be 1, 2 minus minus plus 2, that will become 4 plus 2 mu, and 5 minus 1 will be 4, so 4 plus 3 mu. So this is the direction vector of the line px. Now, substituting this over here, we'll get 1 plus mu, 4 plus 2 mu, and 4 plus 3 mu times by the direction of L, that is 1, 2, and 3. And this will be equal to 0 because we know from the scalar product that A dot B is A into B cos of theta. A and B are the direction vectors. Now, as they are perpendicular, cos 90 is 0, so the right hand side becomes 0. Now, multiplying this, 1 into 1 is 1 plus mu, plus 4 times 2 is 8, plus 4 mu, plus 4 times 3 is 12, plus 9 mu equals to 0. Simplifying, 9 plus 4 is 5, 5 plus 9 is 14. So 14 mu is equals to minus 12 minus 8 minus 1. 14 mu equals to minus 21. So mu equals to minus 21 upon 14, which is equals to minus 3 by 2. Now, as we have the value of mu, which means we can now find the coordinates of x as well. So the coordinates of x, as we already have the coordinates of x in the form of mu, and the value of mu when the lines are intersecting is minus 3 by 2. So substituting minus 3 by 2 over here, so that this will become 4 minus 3 by 2, 2 plus 2 times minus 3 by 2, and 5 plus 3 times minus 3 by 2. Simplifying this, so 4 minus 3 upon 2, that will become, so the coordinates of x will be 4 minus 3 upon 2, that is 5 upon 2. 4 times 2 is 8, 8 minus 3 is 5. This 2 and 2 cancels, so 2 minus 3 will be minus 1, and this will be 5 minus 9 upon 2. So 5 minus 9 upon 2, so that will become 1 upon 2. Now we have the coordinates of x as well. Now we can just simply substitute in the distance formula. So the distance px will be equals to x2 minus x1. So the value for the x value for p is 3. So 3 minus 5 upon 2 whole squared plus, so this is minus 2 minus minus 1 whole squared plus, and this will be 1 minus 1 upon 2 whole squared. Now substituting this in the calculator, we can first simplify this as well. So this will become 3 minus 2.5, so that is 0.5. We can just write it in decimal form as well. And we have to give our answer to three significant figures. So 0.5 squared plus minus 2 plus 1 will become minus 1 squared. And then again 1 minus half will be 0.5 squared. Now substituting this in the calculator, so 0.5 squared plus 1 squared is 1 plus 0.5 squared again. And then square root of the answer, we'll get 1.224. So the distance px is 1.224. And as we have to give it to three significant figures, so the final answer will become 1.22.